So welcome to Vizmath, a MOOC. This is our first session, and we are pleased to have our first speaker here, who I will introduce in a minute. So our first speaker is Apostolos Doxiadis from I think actually Australia originally, then Greece, and he is actually now residing in London. And we're so pleased to have him with us here to talk about math and narrative. And this gives you a picture of him, so you know who is talking, and a little bit of information about him. And I'll be, I expect you to read that slide. I'll be giving some details in the later slides. I actually read some of Apostolos' work with a later book, but I did want to start with an earlier book that I believe was published in 1992 called Uncle Petros and Goldbach's Conjecture. And as you can see from the description, it's a young man and his uncle talking about really what it means to be a mathematician. And it's very well written and very engaging. So I found this just a wonderful way in which to engage with mathematical ideas. The first book I actually read was Logic and Comics, which came out, I think, 2 years ago. And this actually is a comic, in comic book form, all visual, and is extremely engaging. And actually, we use it as a book that we recommend for our students in a history of math course. In finding out more about Apostolos, I found this website of his, and he actually now has an organization that he's had for a number of years, not-for-profit in Greece, of people who want to bridge mathematics and other forms of cultural activity, especially narrative. And out of that group came this book co-edited by Apostolos called Circles Disturbed. And I think later, certainly if asked, he'll explain the title, which I think is very interesting. So I'm going to go back actually just to his photo and hand the microphone over to Apostolos. And why don't you say just a few words about yourself, and also elaborate on what I just said about. Hopefully I wasn't too off the mark, and then I do have some questions for Apostolos.
Okay, thank you, Betty, and hello everyone. I'm, as you said, well, born in Australia, but Greek by descent, and grew up in Greece, and now I'm this year in London for a sabbatical, let us say. And I say let us say because I have no official permanent academic position, but collaborate with many people here and there. And at the center of my work has been writing, not about perhaps mathematics, but I love most of the books of mine that you mentioned. There are others of a totally different kind, but the books that you mentioned all are really stories about mathematics, either real or fictional, or a mixture of both, or real retold in a partly fictional way, or real mixed with fictional in the sense of Uncle Petros, where we have the story of a fictional mathematician, but set in a very recognizable real environment of the development of the theory of numbers in the early 20th century. Now, this is no mission of mine. I'm not, my first name, Apostolos, means apostle, in fact, in Greek, but I'm no apostle of mathematics. I'm not on a mission. I'm a writer. And I just find those stories fascinating. And about the most recent book, which is a scholarly book, we'll maybe talk in a while, because there's a bit more or slightly different stuff. So, well, hi everyone, and that's it for an introductory statement.
Great, and thank you very much. So the first question I have for you is, in your life, you have integrated mathematics and literature. Was this done consciously, and what in your early years led you to this approach?
Well, this is one of those questions an author dreads, really, because one knows that I can try to answer and want to be truthful, but it's very hard in the sense that, I think that the lives of the careers of people who write, or any artist, perhaps any creative artist, move in ways which are somewhat mysterious, in the sense that a lot of them develops in the emotional side of the self, or perhaps the hidden side of the self. I would call it subconscious, if the word was not so overused. So and it seems to me that any answer can seem like an attempt to impose causality after the fact on what was not really causal. I can tell you about Uncle Petros, and it started after I had already written 3 novels, and in the 4th one, I just hit upon this idea of a mathematician trying to prove Goldbach's conjecture as a fascinating idea, in the sense of a person embarked on an infernally difficult mission, plight, and fighting against it, fighting against, let us say, a very powerful invisible enemy. And on the other hand, once that happened, once Petros was out there, and I was not really intending to continue with this, it was not the start of a series or anything, or an attempt to start a new genre, as one critic said, as a compliment, in fact. When after the book was out, there was an enormous amount of reaction and dialogue around it in many countries, because it was translated in quite a few languages. So when I started talking to readers, many of whom were puzzled about the content of mathematics, either very enthusiastic about it, or puzzled, or with questions around it, and so on, I got involved in a dialogue, a dialogue across the frontiers of quite a few countries about mathematics and literature, which they saw at the heart of the novel, that really made me, let us say, stick around and continue. This was, by the way, after the year 2000, when the book was first published in an adapted form by myself in English. Let's say reworked form. The original in 1992 was in Greek, so when the book entered the more international scene, dialogue, it was then that I started to think about the subject at depth. The first time I did it uncritically, because it was a fascinating story to me. It's like, writing a story about a man and a fish, and then finding yourself trapped in a community of fishermen who want more of that. So roughly that's how it started. And then it went on with more material about mathematics, because I found it so fascinating, and especially the dialogue with the readers.
Apostolos, there's some people having problems with the audio, and you are going in and out sometimes, so I don't know if you can get closer to your microphone or not. But I think I can hear you fine, so you can just try to get a little closer to your microphone. The next question is, and that was a great answer, actually. I enjoyed that. Some participants today, and certainly some viewers of this recording, may not share the love for mathematics that you obviously have. How do you see narrative as a way to make math more inviting to them?
Well, first of all, regarding, I see that everyone hears me, so the gentleman who said he doesn't understand maybe meant that literally that I'm speaking I'm saying very complex or difficult or dark or too complicated, things that are too needlessly complicated. I hope I'm not. But these are difficult questions, and when you're trying to put order into things that you have been doing because you like them, it may emerge a bit cryptic, so I don't know. That's what the best I can do. Okay, about, again, I will answer your question, though I will again have to say that that's not the reason I'm doing it. I'm not telling stories about mathematics because I want to make it, I bring it closer to people. I find that, incidentally, a totally noble and worthwhile intention, and it is not foreign to me, and I'm happy if I'm doing it, but that is not the aim, and that's a different thing. Well, I think it's a very simple answer here. There's a very simple answer here, really, which is that narrative, storytelling, is a very basic form of cognitive ability. It is a very basic way for people to communicate with one another. It certainly comes before, historically, than complicated logical arguments. We know from the evidence of archaeology, if nothing else, that people were telling stories to one another much earlier than they were proving theorems or stating geometrical propositions. And this is a very ingrained capacity that we have to create and to understand stories. So I think because the thing that scares many people away from mathematics is what they find its coldness or its abstraction or its intellectual haughtiness, let's say. It is its inability to talk in an everyday, warm, human way. Perhaps mathematics creates a bridge, an emotional bridge, storytelling creates an emotional bridge from the abstract land of mathematics to people's emotions. And once that bridge is there, you can use it also to bring in, to carry over from that abstract land, even abstract emotions and symbols and equations and whatnot. But I think that the basic way that narratives function is because they are more down to earth, they are made out of more human everyday material, and perhaps that helps to kill the fear. I don't know if it actually makes it easier, because storytelling cannot really be about mathematics. It can be about mathematicians, it can be about what they do, it can be about their world, it can be about their emotions and their conflicts, but it cannot really accept complicated notions. I mean, you can create a story if you want to explain, I don't know, differential equations or Galois theory, but even the most complicated story will either be trivial as an explanation, or wrong, or both, or just a bit off the mark. So I don't think it's the aim of storytelling to explain mathematics per se, as to make a way into that territory, which for many people is arcane and forbidding.
Yeah, that's very interesting, and I agree. Although one thing that people say in terms of the learning of mathematics is that if you can connect the mathematical idea, like the differential equation, or like logic, with an interesting story, that your ability to remember it and maybe even reuse it increases. Do you think that is possible, or have you seen people say that who've read some of your books?
Well, regarding it is certain that some stories can give us a better idea of mathematical concepts from the very trivial sense, the stories we we find in school, in lower school, where arithmetical problems are usually stated in the form of, Mary had 4 pieces of candy and she wanted to divide them between her friends and so on. But I think, and that in advanced mathematics, this is much, much more difficult to do in any interesting and complex way. I have a friend who's a very, very serious, very strong academic statistician, and he tells me that in a journal to which he often contributes, the Journal of Applied Statistics, an article will not be accepted for publication unless it describes its main theorem, its main result in terms of a story. And I find that very, very interesting. But again, that would have to do with the fact that it is not just statistics, but applied statistics. So when you're talking, say, about mathematical economics or mathematical sociology, it's easier to have a story. But frankly, I don't think that advanced mathematics can be expressed by stories except in rather trivial or uninteresting ways. Of course, there are always exceptions.
Oh, very interesting. I love your story about the applied statistics. It's very it's great. Well, and actually that bridges to the last question I have. I am thinking of developing an introductory statistics course based on narrative, and so these are for people who have not much background in mathematics. Stories will be used to demonstrate concepts, and then the students will write stories that demonstrate these concepts to them. Based on what you've done in your writings and your work with narrative, can you give me some suggestions on how to do that?
Well, I know very little about statistics applied or other ways. It's not a field I'm knowledgeable in, but regarding if it is statistics precisely, I think it would be good if you could look at some of the articles in this Journal of Applied Statistics, and that may give you ideas. What I do find interesting, though, on the other hand, is stories I think are very useful to talk or think about methodology, especially of complex environments where you have to solve, not say a simple question, but where you have to solve a big, hairy, knotty problem, and you have to first understand where you are, second, understand which way you are going, and third, figure out a way of getting there intellectually, conceptually. So I think the rationale for this, the reason why stories are so good to talk about methodology of attacking difficult problems, is that many stories, and the better classical ones, let's say the archaic, the primeval stories, are really quest stories, are stories about heroes in search of trying to achieve difficult tasks or reaching difficult goals. And those stories are structured very much like the logic of scientific discovery. For example, if you look at a very famous book, the Double Helix by the great American geneticist and Nobel Prize winner James Watson, which is a story in which he recounts his discovery.
I think your mic went off, Apostolos. We only got up to discovery.
Okay, I'm thinking that. Okay, what I'm saying is that the book, The Double Helix, by Jim Watson, is at once the story of a great intellectual discovery by two people over a period of years, working in an scientific environment where others were also involved, especially the great Rosalind Franklin. the X-ray crystallographer. But from one side, it's a fascinating story. From the other side, it is a very precise and meticulous discovery of the stations in a scientific journey, the significant points. What's important is that the story, which connects goals and stations and charts a path, as it were, from station to station until the final goal, is at once the story, the plot of the story, and the structure, the flow chart of the scientific inquiry. So I think that if one reads that book, one understands an awful lot about both the emotions involved in science and the conflicts and the human aspects, but also how we go about attacking a difficult problem in science. Of course, it's not replicable, okay? This is not an algorithm. This is not a how-to little book on solving great problems in biology. But I think, and I have written about this, I mean, if you look at some of the papers that are on my site under the heading Proofs and Stories, there are quite a few articles which discuss and investigate precisely that similarity of problem solving of a complex kind and storytelling. So, yeah, that's it for now.
Very interesting, and thank you for the reference. We've got a couple of questions. I actually had one more and actually it was partly from when we were in this room checking it out, and you were fascinated by the ability to draw on the board, and you were talking about your son learning geometry. What's your sense in terms of the interplay of mathematics, narrative, and the visual aspect of mathematics?
Well, you know, mathematical proof was invented in the 5th and 4th centuries before the Common Era around geometry. I mean, we have highly sophisticated computational mathematics from almost 1,000 years before that in Babylonian, Mesopotamian, and then Egyptian civilizations. But deductive proof was formed around geometry by the ancient Greek mathematicians, and at the heart of their work was a visual understanding. If the compass, the invention of the compass, was crucial to the development of Greek geometry, and the visualizations you could create with a compass had direct analogs in concepts. A compass was most probably invented as a tool to create decorations and vases with, but very soon people saw that all the points on the circumference of a circle were equidistant to the center, and that had fascinating implications about circles inside other circles, or circles touching on the outside or inside, and so on. So I think that in certain parts of mathematics, visualization is important in the creation and therefore also in the understanding. I think otherwise, to generalize from that would not be a good idea, because there are all sorts of levels, all sorts of modules of intelligence involved in the creation and understanding of mathematics, and some are very geometric and some are not. I don't remember who it was, but somebody in the 19th century or early 20th, a great mathematician, said that every mathematician is at heart either an algebraist or a geometer, and I think that about sums it up, in the sense that the sort of mathematics which is visualizable, because it's in essence visual in its conceptual understanding, and there is a part which isn't, which I would say is more combinatorial as opposed to geometric, and therefore less so. So I think it's good as far as it goes, and in some areas it goes an awful lot. But because mathematics and abstract mathematics is a lot about proof and not just calculation or visualization. I think that putting too much of an emphasis on visuals can obstruct the necessity of proof. And I think that proof is more a grammatical category. It's about how you put words together to produce conviction of the truth of a logical result than visualizing things. So I'd say they go hand in hand, and sometimes proof visuals can lead the way, and sometimes they cannot. And if one understands where and which way and how far the visuals can go, it's eminently useful, but it's not all the way.
Yeah, great. Great answers. Thank you. There's a question that Carol had, and I'm going to let Carol go ahead and ask it.
Oh my! Let me roll back. I was asking if you thought perhaps if you were, familiar with the Da Vinci Code by Dan Brown, and if so, what is your impression of the mathematics as a vehicle to move the storyline forward? Can you hear me? Betty? Anybody? Can you hear me? For some reason, I guess I can't be heard. So maybe you can just go to the chat board. Ah, okay. Well, I guess we'll pass on that question. I just found that the use of mathematics in the storyline was helpful. I would have liked to have seen more illustrations of other areas in which phi might have been used in the book of the Da Vinci Code, and I certainly felt that it moved.
I can go ahead. Yeah, Carol, you were very, very light, and the question of Apostolos had to do with the narrative within the Da Vinci Code. And if you're familiar with it, Dana already made a comment that the math there was not correct in all places, but it was an interesting discussion. Got people talking at least about mathematics. So you can talk about that.
Hi, yeah. I was trying to talk before, but as you said, I couldn't get the mic. Now, I've read the Da Vinci Code. I thought it was a lot of fun. And that's when it came out, was 5-6 years ago, and don't remember the details precisely. From what I remember, there were the two kinds of mathematics in it. One had to do with codes and encryption, and the other with a sort of sacred geometry, the symbolic meaning of certain geometric signs. Am I missing anything? Was that about it in terms of math? Can anyone respond in the chats, perhaps? And if what I remember is correct, I found it was interesting and exciting, but again, not too interesting to be not too complicated, not too complex to be interesting. I found much greater interest in the mathematics as a tool of plot advancement in, for example, the curious incident of the dog in the nighttime. I don't know if you know that book. It's a wonderful book. And also the Oxford Murders, or the Oxford Mystery. I think it was published in America as by Guillermo Martinez. So we have Guillermo Martinez and his book, The Oxford Murders, which has very interesting excursions into prime number theory and logic. Okay, the vehicle to yes, okay. I understand that you were interested in this as a vehicle to move the plot forward. I think that mathematics did that partly, but also the solution of all sorts of puzzles and the conundrums in the Da Vinci Code did that. And I think those were, let us so to speak, in the terminology I was using previously, the nodes, the stations of the course. But perhaps to me, what I was referring to earlier was more about the tree, if we are talking the language of graph theory, the tree or the complex or the graph on which represented the course of the action. I think you can solve mathematics, you can use mathematics as a tool to crack a particular enigma, a particular puzzle and go on, but that could be also an answer to a philological question, to a chemical formula or something. I think mathematics, and again I would say graph theory is the field here, is eminently useful in making us understand the course a complex investigation can take. I see the question about James Joyce. Again, I would say, and Ulysses, although it's an even longer time since I've read Ulysses than I'd read the Da Vinci Code. I would say that there too you have this sense of a mystical geometry, symbolic representations. You know, Joyce famously said about Ulysses when he was asked why he used the Ulysses myth and the plot structure, the book structure of the Odyssey to form his novel. He said to get the troops across the bridge. In other ways, that more as a formal device to give structure. And I think the mathematics there, the sort of mystical geometry, the patterns formed by mathematics, the symmetries and so on, are more of a formal device that is a game to create literature than essential to the storytelling. I don't know if any of you know of the work of Oulipo. This is the way it's written. It's initials for Ouvroir de Littérature Potentielle, the workshop of potential literature, a very strong French group that delights on precisely this kind of formalism. They take abstract notions and very often mathematical notions and create literature based on that. So this type of mathematics, both in Dan Brown and in Joyce, they're two different sorts of writers, of course. There's a lot of that, very much of that, in the work of Oulipo. And the great Italo Calvino was a part of Oulipo. So I'm switching off the mic.
It's very, very interesting, and thank you for all the references. And we'll check on those, and if you could send us any more information, we'll add them to the site definitely. And there is a question from Carol, if you can see it, about is Oulipo work in English or Greek. Also, I did want to go back. We do have a participant from India, Gupsabwa Rao, and he had a question earlier about whether, when you were talking about math and emotions, whether there actually was an area called mathematical psychology. So I thought, if you want to address that a little bit, if you've heard anything.
Well, mathematical psychology does exist in the sense that there's a lot of experimental psychology that has to do with statistics, or either at the personal cognitive level or the behavior of groups. And there is statistical study of that, but I would say there's no special kind of mathematics there, in the sense that this is a field of psychology most definitely, and using some rather simple mathematical tools. Of course, game theory, which is a very sophisticated mathematical theory, also has recently entered a lot in the understanding of psychology in applied situations like strategy or organizational behavior and so on. But perhaps there's a lot more there that I don't know.
Very good. And other questions from the group? I think I got to the questions that were in there before. And I'm probably giving a terrible pronunciation of your name, Mr. Rao, but I also talked about Dr. Lang's work in origami, and actually we are having Dr. Lang later in this MOOC in December. Are you familiar at all with his work where he does math through origami?
Are you asking me, Betty?
Yes, you are familiar?
No, I'm familiar with origami. I used to spend endless hours attempting the most complicated constructions as a child and got very frustrated. I was not very adept at it. But no, I do not know at all the work of Dr. Lang, and I'd be interested to. I'll certainly look into it. I've just sent you a link. That's an American mathematician. He's a professor. I'm not sure where. Called Alex Kazman, and he, in case anyone doesn't know his site, which is called Math Fiction, I think, he has done an enormous amount of work, and he has a huge classification of hundreds and hundreds of works of literature from ancient times to modern, going in great detail about the way in which each one uses mathematics, from very trivial ways to very complex ways, from subject to form, and so on. And it's been going on for almost a decade now, and there's a chat group there. It's a very, very interesting resource. We should all see it. But
that's great. I did have a short question from Carol, actually. The Oulipo, is that translated into English?
yes, yes. There is a connection. There is a collection of 2 or 3 volumes of the most famous theoretical writings, or some very indicative works of Oulipo. But of course, 2 of Oulipo's writers. Wait, do you have this? This is so that's the Alex Kazman site there, the Math Fiction, and of course Georges Perec and Italo Calvino are very famous French and Italian writers, respectively, and they are both members of Oulipo. So their work is, yes, very much so available in English, as is as are the theoretical writings. See, if you Google Oulipo, O-U-L-I-P-O, or go into Amazon even or somewhere, I'm sure they have their collections of writings.
That's great, and it's wonderful that you're sharing such an international collection of materials that I don't think many of us in the U.S. are familiar with. Are there other questions from the group? Dana, do you have your headset on? Do you want to try talking? Apostle, she's going to be talking about crocheting and hyperbolic space next week.
Hi. So first of all, I'm the one who is doing mathematics mostly visually, because I think that's advantage of visualization is that you don't need translation. You can immediately see in your first language, since we both are not speaking English as our first language. I think that you would agree with that. Well, I was just like curious because I didn't find, what is your mathematical background?
What is my mathematical background? Was that your question? Because I cannot hear you very well.
Yes, yes. Well, so what was interesting to you in mathematics, and what did you do for your? Okay, now do you hear me better now? So yes, what's your mathematical background?
Okay, well, I studied mathematics. I studied mathematics in America. I was at Columbia University my first degree was from there, and then I went to Paris, which was in the mid-70s when I was studying a real hotbed of mathematical activity, and I did mostly logic, and also what was very fashionable then, but is not so much now, not in the same way, a lot of applications in the study of the nervous system and networks of neurons. And I spent quite a few years after my studies, and still am, in fact, an amateur, let's say, of mathematics in the French sense, a lover, but also a non-professional. So I never did hard mathematical research, but I read an awful lot about developments in mathematics from the outside. You cannot really understand the hard stuff unless you're doing it, unless you're at the frontiers of research in the field. So I would say I have basic mathematical literacy of a rather, solid kind, and I do know a bit of many fields, but I'm definitely no expert in any one of them, if expert means active researcher.
Thank you. I think that the others were also interested in this question because that kind of gives impression what you are doing. And well, maybe you can share with us what are your other hobbies besides mathematics and writing.
Okay, I don't know if that is of interest to anyone. Well, I would say I'm in that way rather a typical, what the French call homme de lettres, or a man of letters, or writer, in the sense that I read a lot of literature, I read a lot about history and about philosophy and about intellectual history most particularly. And with the writing I'm doing, with the research I'm doing in the history of mathematics, and with 3 children and a very active family, I think I have all the hobbies in the world I need.
Thank you very much. I really actually enjoy your books. I have read them.
Thank you. I'm glad to hear it. Let me get this question here. I'm reading a question which says, does the mathematical element in fiction make it easier or harder to translate from one language or culture to another? Well, I'd say easier,
Apostolos, you lost the mic, so we heard up to that's easier.
Indeed, the mic is there now. Okay, so I was saying that mathematics definitely makes it not perhaps easier to translate, but in terms of language, but certainly easier to communicate. For example, I've traveled in many countries to speak about my books where they are published and where they've invited me, and I'm surprised that in most countries, maybe in all countries, most of the questions are the same because the books are read with people who have an interest in mathematics. So they respond perhaps to the same kind of dilemmas or issues in them that have a lot to do with the essence of mathematics, and that is an international conceptual vocabulary. Of course, they may also have to do with, because like all stories, they're about human beings, and human beings, all differences from culture to culture aside, do tend to have a bit of the same worries and conflicts.
Actually, Apostolos, there's a question there from Mark, who's one of our faculty who teaches students of all levels, especially our introductory. So just more generally, do you have some ways where you can get people interested in reading mathematics?
Yes, I do, but that perhaps does not come so much from my experience as a writer as my experience working with schools in Greece, which is my base. I'm in London for a year, as I said, but Greece is my base. 6 or 7 years ago, a group of friends, one is a professor of mathematics at the university, the other two are math teachers, and myself, we started a group called Thales and Friends. Unfortunately, the most interesting part of its educational work is not on the site. We are now working to translate that because a lot of that is in Greek. What we did was we went to schools and we found teachers there who were volunteers in that, and that really means who were keen, to create what we called mathematical reading groups. Now, after 5 years, we had 300 fully operational groups all over Greece, some of them in villages or very small towns, and which is quite astounding, really. And it shows how far, how much the need was there for it. And what they'll do in these groups is students and the teacher will meet once a week, as a rule, a fixed day of the week that they decide on outside school hours, and talk about the book they are reading. They will decide on a book that is either a novel around mathematics or a novel or a book of mathematical biography or history, or a book of popular mathematics, say like Simon Singh's Fermat's Last Theorem, or the many books on the Poincaré conjecture or Riemann hypothesis and so on, or code breaking. They will choose one of those books and read, say, a chapter a week at home individually, as you would in a reading group, and then meet up and talk about it. And of course, our advice to the teachers as motivators, as facilitators, is to be precisely that. I see Mr. Rao's comment about not having good libraries in India. I guess he's talking about India, but you don't need the libraries really, because what we do is we will take, usually for each school we'll find one book per year. We'll do one book per year. And it's amazing how the work on it expands to fill a whole year, to fill the 20 or 25 meetings that you can have throughout the year by meeting once a week. And if it's a very poor school with poor students, they will buy one copy and share it. And if it's the students can afford it, they will all buy a copy of the book. A book a year is not the end of the world after all. But they will really go into it, and they will do a lot of research around it on the web, and contribute to the discussions with talks and presentations. And our advice to the teachers, as I was saying, is not to be teachers there, but facilitators, to make this able to happen for the students and let the students to be actively involved. What we've found is that students, about half the students who attend these groups are already interested in mathematics, but interestingly, half aren't. They go for the fun, they go because they like the teacher, they go because their friends go, they go because it sounds like an interesting thing to do, like an interesting group activity. And if you don't scare them off with too much math and insist that this is about the stories and not the mathematics, then a lot of mathematics comes into it, and we've seen great improvement in the feelings towards mathematics of really everyone who attends. I could tell you, soon I hope there will be a written form of our presentation of our work in English, which people can read, but the basic ideas I already spoke about.
That's wonderful, and thanks, Mark, for the question, and thanks, Apostolos, for sharing that about the reading groups. I think we've got time for one more question, and there is one up there from John Griffin for you, Apostolos. I'm moving up to it. Oops. What challenges did you face in translating mathematics to the format of a graphic novel? How much did the illustrated nature of the work influence the way you communicated your message?
Okay. First of all, let me answer briefly a question I saw here from Mr. and Mrs. Robinson, Marjorie and Gary Robinson. What age groups for the reading groups? Well, we started from with high school ages, that is from 12 to 18, different groups. Now, then we got some very keen primary lower school teachers involved. So also we have groups working from, say, 6, not 6 perhaps, but 8 or 9. But we have found that students of different ages sometimes respond in very unexpected ways. For example, we found that books which we thought were for 18 or 20-year-olds, like, say, Fermat's last theorem, would suddenly be chosen by 14-year-olds, and so on. So I think, if you go into Alex Kasman's site, which is about fiction, that's the only problem with the site. It is only about fiction, and as far as fiction goes, it's great, but there's also history, there's also biography, there's also good narrative popularization, and there's an infinite amount of good books out there. Well, as I'm speaking to mathematicians, I shouldn't say infinite, but there's a very big number, and surprisingly big, I would say, on any field of mathematics imaginable, and more being created. Now, as for you can find many books which would fit any age group, really. Now, as for the graphic novel, for logicomics, and how was it to use a visual language, I would say I would separate the conceptual from the narrative. I would say that in the narrative aspect, it was as good as it is for any subject that the comic book picks up or a film picks up. Visual narrative helps make it more engaging, more fun perhaps, more, for some readers, more easy to get into. And it helps you give a sense of atmosphere, of era, of a particular time and place. And I found that, for me, very strong. As a prose writer, I don't really like writing description. He entered the room and the room was so and so. I don't like that kind for me. It's not that I don't respect it. I just I don't know, maybe I cannot do it well. So in a graphic novel, it was very useful to have all done that by the artist, and me to deal as a writer with the ideas and the concept and the conflicts and the emotions. But then there was the aspect of explaining ideas visually. And that was great sometimes in an unexpected ways, because, logicomics is about the development of formal logic. And suddenly you would have an idea such as, say, a maze, a logical decision tree, or Hilbert's hotel and the notion of an infinite amount of rooms and how you can create that with finite means, and self-referentiality, something referring to itself. And suddenly we would discover that those concepts had very interesting visual analogues. Like, to give a very elementary example, self-referentiality, you would have an infinite regression of images in mirrors, or in the Hilbert Hotel, you could actually see the movement from room to room on a plan of the hotel. And all those were very interesting and fun things to play with. I'd say that we discovered most of those as we will get going along. We didn't start in order to be able to use these tools. And just give me a second to look at the latest questions. And I'm getting off the mic now.
Actually, this is something that sometimes happens, Apostolos, in a MOOC is sort of a sidebar. And there is this woman, V. Hart, who's recently was hired by Khan for Khan Academy, who does this doodling and does some kind of fun things. She talks very fast, but she's kind of, I think the idea is to get people interested in math, and she says, and she's doodling while she's bored in math class. So there's some, so that's what some of the conversation is about.
I think we're just about at the top of the hour. This is Carol, if you all can hear me. So Betty and Apostolos, if you have any closing remarks, it might be good to do them now. I will certainly say thank you very much. I am not a math aficionado. A lot of what Apostolos has mentioned today makes me far more interested. So hopefully the math lovers will also be challenged and want to delve more into mathematics.
Yes, thank you very much, Apostolos. You've got us thinking in many different directions, as you can see, and it was just wonderful having you with us for our first MOOC. And I'm going to end the recording now, and in order to finalize recording, you do need to actually exit the room. And thanks again, everybody.
Thank you all.